Hello, everyone. This is Ahmed El-Koutbiya from INNOSOFT Gulf. I would like to welcome you to our AI and big data and machine learning seminar today. If you can hear me, can you please send me a message in the message box or in the chat window? Okay, perfect. Thank you, Zabi. So great, fantastic. So we will go ahead and get started with the presentation right away. So today we are essentially going to focus on three fundamental topics that many of you probably are interested in, which includes obviously big data, machine learning, and deep learning. And before I get started, I just want to share with you a few things about my background. I am a data scientist at INNOSOFT. I worked and lived in the US for over 10 years. I went to the University of Illinois at Chicago. And then I worked for a couple of large companies in the US. One of them is Sun Microsystems. I don't know if you remember, I was in their software architecture group. And I also was working at the Chicago Board of Options Exchange, which is one of the largest option exchanges in the world, where we developed a what we call screen-based trading application that enables investors to execute transactions after the trading hours. So you can imagine in the stock exchange, we was handling quite a bit of data. So today my hope is to be able to share with you some ideas and some practices or best practices when it comes to machine learning, when it comes to AI, and when it comes to big data. And we will first start with the presentation. And by the way, just for your information, this presentation is actually recorded. And we will see if there is an opportunity to share it with you afterwards if you want to review some of the material that we covered. So that's basically it. Towards the end of the session, what we will do is we will have a Q&A session. So I know some of you are probably considering a career in AI or data science or big data, and you have questions on how what are the courses or what are the learning paths that you need to follow to be able to develop your career as a data scientist. So basically, these are the things that we will cover. So if you have questions, we will have Q&A session for the people who have decided to stay. I will provide you the opportunity to ask questions live, and we'll have a live Q&A session towards the end. And based on my experience, I noticed that that session, for many participants, we've done like hundreds of these events. As you probably know, INNOSOFT is very well-known organization in the UAE, which is focusing mainly on education and consulting around AI, machine learning, and deep learning. We have one of the largest meetup groups in the UAE. I think it has like 3,600 participants or more. Many of them are data scientists. And we have organized more than 200 events in the last couple of years. So yeah, so my hope is that obviously towards the end of the session, we will have a Q&A session where you can ask me questions, and hopefully I can provide you the right answers. Okay, great. So with that being said, we can go ahead and start with our presentation. So the first question that we want to ask is, what is big data? So like sometimes when we are in an interview situation or when we are talking with a client, very often the question comes up is like, what's big data? And so typically one of the best ways to answer that question is to think in terms of what are the characteristics of big data. 4 characteristics of big data. One of them is the volume. So obviously we can't really talk about big data without the idea of handling a large amount of data. And the question here is, how big is big data? Well, typically when we are working with big data, this is going to be in terabytes or petabytes. So we're talking here about large volume of data. Because of the acceleration that we see right now in digitization, and because of now millions of or billions of people have mobile devices, we are seeing really a very rapid growth in the data that we have. In fact, there was a study that concluded that every 2 years, we double the amount of data that we have. probably took us hundreds of years to be able to double the data that we have. But now with this acceleration, it's like every couple of years, we double all the amount of data that we have as a human civilization. The other characteristic that is also important when we to look at when we think about big data is the variety. So by this we mean both structured and unstructured data. Question here is, what is structured data? So structured data would be data that has a predictable format or schema. Examples of that would include spreadsheets, database tables. For instance, if you have a CRM system where all the data is basically in a predictable format, the same customer record or product record, it follows exactly the same format. So that's called structured data. For many years, companies have been organized to work with structured data. So that's why you have databases like Oracle and SQL Server and so forth. What happened recently is there is an explosion of what we call unstructured data. So what is unstructured data? Unstructured data is a data that does not have a predictable format, and it includes images, it includes videos, it includes social media content. So these are all examples of unstructured data. And again, there was a study that was done that says that like over 80% of the data that we have today is actually unstructured. So all of a sudden, organizations are waking up to the fact that we have this huge amount of unstructured data that we can also try to get insight from. For instance, let's think about some use cases. One of our customers, we worked with Emirates Airlines many times on different projects. They might be interested to look at, for instance, a tweet or a Facebook post. And from that textual content, we want to identify whether the customer is happy, satisfied, not satisfied. So the input would be like unstructured data, and the output would be a classification of how the customers feel about the product or about the brand. And this is called sentiment analysis. Now, we can think of other examples where we can use unstructured data, like for instance, in a self-driving situation. A little bit less than a year ago, I was working on a project where the input were images. So this is a self-driving project. The images were from Beijing, China. And so you take the images in, and then you try to identify how many lanes are on that particular image. And the question is, why is that important? Well, again, if we think about a self-driving car, it needs to identify how many lanes are on the road and which lane the car is on. So this is an example where we can also obviously rely heavily on unstructured data. Okay, now the next characteristic of big data is this idea of velocity. And velocity basically denotes the speed at which the data is generated. You probably have heard of IoTs or Internet of Things. So these are sensors and devices that can capture data and then can stream it, live measurements. It could be temperature, it could be pressure, whatever the measurements are, we are getting a constant stream of live data coming in. And if we have such data coming at a rapid rate, then we need to think about where are we going to store this data? How are we going to handle this data? Yeah, so that's something to keep in mind. And the last element here in terms of characteristics is called veracity. So this is not a very common word. We don't use it very often, but it just denotes the idea that how accurate our data is. Because as we will see later, the foundation of all the work that we do in machine learning or AI is data, right? So we want to ensure that whatever data we have does not have any kind of bias. And the bias could be a gender bias, it could be economic bias, it could be age bias. So we want to ensure that whatever data that we have is actually accurate data, and that's what veracity means. If we have a huge amount of data, then fundamentally we have two problems. One is data storage. Where are we going to store this large amount of data? And then the second problem is, how are we going to process this huge amount of data? If we do take a moment to reflect on this, if we have a huge amount of data, we can't store it on a laptop. cannot store it even in an enterprise server because, again, you have a huge amount of data. So that leads us to think of what type of architecture, what kind of setup we need to be able to store large amount of data. Once we store it, we can also think about what kind of components or modules that we need to use to process this huge amount of data. That's basically the point that we are going to cover in the next few sections. With respect to data storage, so one of the first ideas that came about is this idea of a scale-out architecture. Notice here what we have is this architecture. It says, okay, what we are going to do is we are going to take commodity hardware, which is a kind of fancy word for like cheap computers. We're not going to buy expensive servers, basically just cheap computers, and we're going to get lots of them. They can be physical or they can be virtual. And then we are going to scale out the architecture, and I will explain that in a minute. So let's say a client comes in and it wants to store like 2 terabytes file. And each one of these nodes can only handle 500 GB, okay? So clearly we cannot store 2 terabytes on one single node. So what happens is that file gets divided into blocks. It gets cut into blocks, and the size of each block, as you can see here, it's like 24 MB to 128 MB. And this data gets distributed across this, what we call the cluster. So this is a cluster of nodes. And obviously, if this data is going to be clustered, we need to be able to remember where the data is stored and so forth. So that's the job of what we call the name node. So the name node, it will actually help us find where the data was stored. And the data nodes, as the name implies, that's where the data will actually be stored. Now, because we are using commodity hardware, it's possible that one of the nodes will go down, right? Because hard drives, they can fail. And in case of failure, we want to be able to recover the data. That's why we have what we call a replication strategy. And what this strategy basically implies is this idea that we are going to store like at least like 2 or 3 copies of each block, so that if one of the nodes goes down, we can still recover the data. Okay, so this is called HDFS. Initially, the concept was actually a subject of a white paper that was delivered by Google, and it's called the DFS, stands for Distributed File System. And then later on, there was an implementation of HDFS, which is called Hadoop Distributed File System. So you probably have heard of Hadoop. And so one of the components that Hadoop provides is the HDFS, which enables us to store large amount of data across multiple nodes. Okay, now the next thing that I would like to talk about is data processing. So if we are going to have data stored in a distributed manner, we can easily make the observation, well, if these nodes, they have some processing power, wouldn't it be nice to also be able to do processing of the data in a distributed manner? And this might sound like a complicated concept, but it's not really. So if you can think about a situation where you go to a supermarket like Carrefour, so you can imagine if you have multiple cash registers, then customer orders, they will be processed a lot faster than if you have just only 1 or 2 cash registers. So that's the same thing. And then one of the algorithms also in the big data ecosystem that enables us to process data in a distributed or parallel processing, doing parallel processing in the data, it's called MapReduce. So in a MapReduce situation, you would have an input. The input, whatever data, gets divided into partitions, and each partition will be processed by a given mapper. So notice that here, for instance, this is a trivial example from natural language processing where we really are just want to know what's the frequency of each word. Let's say in sentiment analysis, we have a statement and we want to say, is this statement positive or negative? So one approach we could think about is to count the number of positive words or the number of negative words. So if we have lots of positive words, more likely that this statement is a positive statement or positive review, for instance. This algorithm does is not all that exciting. The interesting part is how it does it. So here we have a statement right here, and then it's divided into like blocks, and each mapper is given a part of the statements. Like the first part is how many cookies could, and the second part is a good cook if a good cook could cook cookies. And notice each mapper will be provided one partition, and the output from the mapper would be just the word and then the frequency, right? So that's step number one. And then step number two in this algorithm is to do what we call sorting and shuffling. First, we want this data to be sorted in alphabetical manner. And notice as it stands right now, it's not sorted. So what we do is first try to sort the data. So we are going to kind of shuffle some of the words. Some of them will be here and some other ones would be here. And we have another component here called a reducer or a reduce component. So what a reduce component does, it will do aggregation of the data, or it will enable us to produce a summary. So in our setting, what would be the summary that we are looking for? Well, we would be looking at the word and how many times it's been mentioned. And that's what the output from this first reducer. And then this is the second reducer, and we can see here clearly the output. So it turns out that this particular algorithm could be used in lots of situations to process a huge amount of data and do the processing again in a distributed manner. And because it's doing the processing in a distributed manner, we can be confident that it will be done much, much faster if we are relying on one single server. Okay. So basically this is, so some people who could be interested in using MapReduce, they could be asking the question, okay, great. We are ready to use MapReduce. What kind of technical skills we need to be able to use it? Well, it turns out that MapReduce is written in Java, but it also has an adapter that you can use so you can write Python code, which means that if we want to work directly with MapReduce, we need to know either Java or Python. Probably some of you could say, well, I don't have anyone in my team that knows Java or Python. I have data analysts. They know SQL. That's the extent of the skill sets that we have in our department. Well, for that, in the ecosystem, we created a couple more components. One of them is called Hive, which will enable you to write SQL queries that get translated into MapReduce. So it's like another layer on top of MapReduce that will enable you to write SQL queries. That way you do not have to write neither Python code nor Java code. And for instance, people who are from a system administration background, there is also a scripting language that can be used. It's called Pig. So this is a scripting language that's easy to learn, and you can also use it to run MapReduce queries. But again, Pig runs on top of MapReduce. However, if performance is a consideration, notice that with Hive and Pig, we have to write a script in Hive, it gets translated into MapReduce code, then the MapReduce code gets executed. So notice there are lots of steps. If performance consideration, in terms of processing the data, then this approach probably is not the fastest. And we have here this funny analogy, mentions the fact that if you are using Hive or Pig, it's like driving a Toyota or a Nissan versus a new component that we have in the big data ecosystem called Apache Spark. So what Spark does is it says, well, look, if we are going to process a huge amount of data, if we every time have to go to the hard drive to store the data, this is going to take a long time. So what Spark says, let me just show you the architecture here. It says, look, what we are going to do is we're going to go to the disk or the permanent storage and load all the data in memory caches, which implies that with Spark, we need a lot of memory. Now, if this was proposed maybe 20 or 30 years ago, this would have been an expensive proposition. But thankfully today, the memory is cheap. Therefore, we can afford this. In other words, what we can easily build a Spark cluster. In fact, I'm going to show you that in a moment, that you can load data in memory, and all subsequent write and write operations will be done from memory. And it turns out that this approach, it's really, really fast. If you go to spark.apache.org, they claim that they are 100 times faster than if you are using like Hadoop, for instance, MapReduce. I don't know specifically whether it's exactly 100 times faster, but I can tell you from experience working with large data sets and using Apache Spark, it's pretty fast. And I believe you will have the opportunity shortly to witness that yourself when we look at a lab. This slide here, what it does, it will provide us with just a summary of, basically what are core components in the big data ecosystem. And I just want to mention the fact that there are so many components in the big data ecosystem that we cannot possibly represent in a single slide. So here we are hoping to just capture the important ones, or the ones that are frequently used. So as we mentioned, we start first with data storage. So we take in data that can be structured data or unstructured data. So here we have structured data or unstructured data. We do what we call data ingestion, and we put that data into HDFS. So that will enable us to store the data. Next, we have this component called YARN. So YARN stands for yet another resource negotiator. So you can think of YARN as the operating system of your cluster. For instance, YARN provides a command line interface that you can use to monitor an application that's running on your cluster. I remember I've used it in the past where, for instance, an application is stuck. So I can just go to the YARN command line interface and then terminate the application. You can think of YARN as your task manager in Windows, where if an application is stuck, you can go there and then you can kill the application or manage the states of different applications that are running. Okay, so on top of YARN, as we mentioned, we have Spark. You can use Spark for data processing, or you can use Pig, or you can use Hive. We talked about Hive, and there are other components that we can use. I'll just mention a couple of them. HBase is what we call NoSQL database, and also in the big data ecosystem, there are some important tendencies that basically state that, look, there are some queries that sometimes we need to do that we really don't need necessarily an SQL database. It's basically the same query, like searching for a book. So here, these databases, they rely on this idea of key value pairs to be able to search the database very quickly compared to if you are using a relational database. So that's why we call them NoSQL database, which stands for not only SQL database. And there are like 3 databases in this category. HBase is one of them. There's another one called Cassandra, and MongoDB. It's the 3rd one. So if we have this cluster, then we need to have some kind of interface that will enable us to manage this cluster. And there are lots of dashboards that we could use. One of them is called Ambari, that will essentially provide you with the dashboard so that you get to know, how is your cluster doing, how many nodes you have, how much storage you have, how much memory is available, and so forth. Okay. So what I will do right now is I will switch to our lab mode, where I'm going to show you how we can go ahead and use HDFS and Apache Spark to process 20 million records. If you remember in the description of this event, we mentioned that that's something we want to do. And therefore, I'd like to demonstrate that. So what I'm going to do now is I'm going to switch to our lab environment. So this is basic, excuse me, just one second. As I'm going through these examples, I want to mention one thing so that you can have an idea. Some of the examples I'm going to mention is from actually a course that we have, and I just will mention it so that you have an idea about which course I'm talking about. So if you go to INNOSOFT.ai, and if I go to this blog post right here, and here if you look at our June-July training schedule, And so this is the program that I'm going to pull some examples from. It's called Artificial Intelligence Professional Program. And that also will help you to have an idea about like what we really are discussing in this course. Okay, so this is the course in question right here. So I'm gonna show you, these are all the modules that we discuss. It's an 8-day program or 2.5 hours per session. And I'm going to go ahead and pick the big data module. Now, one of the things that's also important, and this is a feedback that we're getting from lots of students and professionals who are attending these programs, the fact that setting up a big data infrastructure is not easy. And even working with some of the AI components, basically there are two parts to it. There is the setup, the configuration, and then there is the implementation where you actually build the algorithm. So I don't want to make this look really super easy and straightforward because there is a setup that needs to be done. For instance, to be able to store data in HDFS, well, guess what? We need to have a cluster set up, make it easy for our students to help them focus only on doing the data analysis and doing things that are associated with the data science program. Some of them who are interested to know how they can actually set up this, then we have some resources that they can use. But for all the sessions that we have, each student would have a dedicated lab that they can access actually this particular infrastructure. So the first thing I want to mention is HDFS. So let's go ahead and talk about it for a moment. So as I mentioned, if I go back to so here is this is like an interface that which can help us identify, like what's happening with our Hadoop environment. And notice here, I have just a very small cluster that contains 2 nodes in our lab environment. This is just for testing purposes. In a production environment, you could conceivably have hundreds and hundreds of nodes. So you can scale this very fast if you have lots of data. So we have here 2 nodes. And then I've already uploaded a data set, which I will show you where I got it from. So I went to this website called Movie Lens data set. And if you look at 20 million records right there, there are different data set. Notice that today they have even 25 million records. Yeah, so here you can see 25 millions. I got one that has 20 million records. I think it's good enough for this demonstration. So what I did is I downloaded it and I've uploaded it to our HDFS environment. Yeah, right there. So here, if I go to our, if I browse the file system, and notice here I have 20 ML, which is movie lens data set, 20 million records. And then these are all the files that are in the data set. Well, notice that imagine you are in a situation where you are given this data set and there is one particular file called ratings.csv, which basically contains information about movies that have been rated by multiple users. So look at the size of this file is 508 MB. So for instance, if you were to process this with Excel, I don't even know if you can open it in Excel, but it is a large file. So, and this is not a huge data, but it's still big actually. It's 20 million records. So let's have a look at it. So you can look at the head of the file. And as you can see, the first value is the user rating. The second one is the movie ID. That's the third value is the actual rating, which is a value between 1 to 5. And then this is the timestamp where the rating was done actually. This is the input. And what is required in this project, let's say we have a company that gave us this project, is they want us to take this data set and produce the top 20 movies, and produce a report. And there is another file that we're going to use called movies. So let me have a look at this file. So you can see here, you have now a mapping between the movie ID and the name of the movie, and then the genre or the categories that this movie belongs to, whether it's an adventure or drama and so forth. Yeah. So what we are going to see is that, again, the idea, this is just an example. What I would like to help encourage all of us to see is how you set up the HDFS environment, you store the data into the HDFS environment. Now the data is there, you don't have to worry about it. Anybody can access it and do data analysis. It has a web interface. And then the next step is to be able to process this data. Well, as we mentioned, the core components that is popular and it's used today for doing big data processing is called Apache Spark. And that's exactly what we have here. So what I'm going to do right now is to clear all the cells. Let me just go ahead and then I want to change the name of the file that we want to produce, the top movies. Let's call it V3, for instance. So for some of you who are not from a technical background, probably from a business background, what I like you or encourage you to do is to just observe the process and the methodology that we are using here to be able to gain insight from this data. So again, what do we want to get really out of this data set? Well, we just want to produce a report that says, here are the top best movies. How do we know if a movie is really a good movie? So in this case, in fact, we're going to look at two measurements. One is how many times that movie has been rated. Notice if a movie has been rated quite a bit or has the highest rating, it might not necessarily be the best movie. A popular movie doesn't necessarily make it a great movie. So we need to look at how many times a movie has been rated and the average rating for that movie. People could say, well, why can't we just use the rating or the average rating for that movie? Well, the thing is that movie could be rated by only 1 or 2 people. So that would not be really a legitimate or rating. So we need the movie to be rated like by at least 50 people, you know, so that we can consider it as a good movie. So what I'm going to do right now is I'm going to go ahead and run this, and then you will get to see how fast we can process 20 million records. So let me go ahead and do that. So I'm going to run all. So basically, when you see start, that means it's running. So here we are loading a file that has a size of 500 MB. So notice it's already been loaded from HDFS. This shows us the content of the file and the fields. And here, as I mentioned, we have 20 million records. So you can see clearly that represents 20 million records. You may want to just across 20 million records say, well, I just want to know what's the average rating across this whole data set. Now you can use this describe method to provide you the mean, the standard deviation, the minimum rating, and then maximum rating. And here, for instance, we are really not interested in the timestamp. We are just interested in the movie ID, the user ID, and then the rating. And then notice the first thing is we want to group the movie by the movie ID. In other words, we want to know for each movie, how many times has it been rated? And notice right now we have an idea, you know, how many times each movie has been rated. So for instance, notice the movie 296, it has been rated 67,310 times. So here, what you can see here is that I have the movie ID and then the average rating per movie. And then what we are going to do now is to sort the data based on the average rating. So notice that this movie has a perfect rating. The only problem with these movies is they might be rated by like maybe 1 or 2 people. So what we are doing here is we are joining 2 tables, one which contains the ratings and the other one contains like the movies. So notice here, what we are doing is we have a rating and then we have the movie ID and then we have a count. So this is good because I can see that, okay, I have this rating, but it's been rated 357 times, you know, so that you can get an idea about, you know, you can look at 2 values, the average rating and how many times the movie has been rated. What we could do is we could try to sort the data. And I just want to go quickly so you can see here that, for instance, now when we produce this particular report, you can see this movie 318, it's been rated 63,366 times, and the average rating is 4.45. So that looked like a really a good movie. And obviously we want to know what the name of that movie is. So for that, we are going to link this with the movies file, which is movies.csv, which contains a mapping between the movie ID and then the title of the movie. And that's what we are doing here. So this would be like the final report. So notice that movie is called Shank Redemption. This is like a list of the top 20 highly rated movies. And then once we do this processing in the cluster, now we are ready to collect this report and get data in our laptop. So that's exactly what we are going to do right here, is to collect the data and then store it in this file called topmovies-v3. So I'm going to go there and see if we actually have that file. So if I go to data sets, and if I look at the top movies, actually it's a directory, v3. And notice it has a file called parts. So this file, notice I get a message here that says success, and this is the report right here. So if I just want to look at it, I do less this file, and then you can see now this is the final report that we got. Okay, sure. And by the way, what I've just shown you, this is a setup I did in our office. So all the components that I've shown you, they are open source components. And you know, you don't have to pay anything in terms of licenses, and you can use just a couple of 2 or 3 machines if you have them in your office or in your house to set up a Hadoop cluster and then process it like I demonstrated here.